So machine learning is just giving machine some parameters to predict or to classify and find patterns in between the data. So it's nothing but machine learning is just the three goals of machine learning is that we are giving some parameters to predict or to classify and also to find the pattern in between an unknown data or even the known data. So I hope you could understand what data is all about, because data is nothing but any kind of countable things. If you have a 10 balls in your hands, it's called as data. And if you have your contact list is in data, and whatever bio info you have uploaded in Facebook is a data for them. And literally data is everywhere and everything. So for example, if we have 10 balls, we can classify these 10 balls into categories as cricket ball, basketball, or football. And on what basis we'll be differentiating is that we can differentiate using their color, their dimension, their texture, and even their elasticity. We can easily classify the ball type using these criteria. Now, if someone say a ball of red color and thread stitching on it, we can predict easily that it is an cricket ball. So that's how the machine learning is going to be. So in machine learning, to be in more real words, it's about a subset of artificial intelligence which provide computers with the ability to learn without being explicitly programmed. I'll repeat it. So it is a subset of artificial intelligence which provide computers with ability to learn without being explicitly programmed. It means that we don't need to program every line or for every task or every new stuff we are going to do with the machine. It learns from itself. We are first, machine learning is nothing but we are programming the computer to learn by itself for tackling new problems or for new purposes. In machine learning, we do not have to define explicitly all the steps or conditions like any other programming application. On the contrary, the machine gets trained and training data set large enough to create a model, which helps machine to take decisions based on its learning. So these all data set, models, algorithms are a bit confusing, or for it will be finding a few of them will be finding it difficult to understand. I'll explain it clearly what are these terms in this session. So starting on with dataset. Dataset is nothing but a basket full of data. Or if you collect a whole bunch of data and you keep it in your any kind of storage, that's it. That's called as a dataset. We'll be using these dataset to train the machine to learn itself. So we'll be training the machine to understand the data set that or the data which we are being providing to it. And then once it is well trained, it will create a model in the sense it will create a prototype, or it will create a function which helps the machine to take decisions based on its learning. So this function or model will be used by the machine every time when a new problem approaches it. So that's what called as a data set and model. So now what is an algorithm? Say algorithm is nothing but a recipe for how to work out on an answer from a problem using very simple steps. As I think I have explained what an algorithm is in the previous session, and I'll repeat it. It is nothing but a cooking recipe with a simple steps where we need to follow it one by one. And that's what called as an algorithm. And this is important, like it is important in all programming because algorithm is a vital role, or it is a basic of programming. Even if you don't know how to code, one must have a knowledge enough knowledge about creating an algorithm for a problem or for any kind of use case. So any given computer is made with a long list of simple steps it can take, but it doesn't understand what happens when they are taken. So the programmer has to describe what to do, where, and when. In this sense, there is not really a difference between algorithm and program. But generally, algorithm refers to a method of accomplishing something without describing it for a specific computer. Whereas implementing the algorithm means starting from the operations given in the programming language and writing out what algorithm needs in terms of operations you have. It's so to be in a nutshell, we can say that algorithm is something not just for a specific computer. You can implement it almost in anywhere and everywhere. So that's what the algorithm is mean. And machine learning algorithms use statistics to find patterns in massive amount of data or in the data set. And data here encompasses lots of things, like I said, numbers, words, images, clicks, whatever you have. It can be digitally stored, it can be fed into machine learning algorithm or anything. So machine learning is a process that powers many of the services which we use today, like recommendations like from Netflix, YouTube suggestions, and even in Spotify, which song you hear, you once hear a good melody, love song, or a soup song, and then it will just adapt it and it will learn that this guy or this girl needs something to this genre of music, and it will suggest by itself with the same genre of another music. And even in search engines like Google or Baidu, machine learning algorithms are vastly used. So, and to be more into the real life application, even in social medias feeds like Facebook feeds, Twitter feeds, Instagram feeds, or in voice assistants like Siri, Alexa, Google Assistant, everything works on the machine learning algorithms. So once you learn an machine learning algorithm, not an algorithm, you can learn a number of algorithms you want, and it will be vastly used in many areas, and it's something not extinct, or it will not be expiring. So you can use it in many other ways in the future. So in all these instances, each platform is collecting as much as data about you as possible. What genres you like watching, what links you will be clicking, which statuses you're reacting to, and using machine learning to make a highly educated guess about what you might want next. Or in the case of voice assistant, about which words match best with the funny sounds coming out of your mouth. The voice assistants will be adapted to your slang, or it will be adapted to your language very soon. It depends totally on how much it is being trained. Trained in the sense how much you are being used is directly proportional to how much it is getting trained. So frankly, this process is quite basic. Find the pattern, apply the pattern. But it pretty much runs the world. That's the big thanks to an invention in 1986, courtesy to Geoffrey Hinton, today known as the father of deep learning and machine learning. So he is the one who created these kinds of algorithms and the method of learning or method of machine learning. Deep learning is a machine learning on steroids. It uses technique that gives machines an enhanced ability to find and amplify even the smallest patterns. This technique is called as deep neural network. Deep because it has many number of layers of simple computational nodes that work together to munch through data and deliver a final result in the form of prediction. So deep learning is nothing but a fuel, or it is an working principle which enhances the machine learning to work efficiently. This has deep learning has n number of layers, hidden layers, which helps the machine learning algorithm or machine learning method to find deep insight patterns of a humorous data set. Now, what is a neural network? Neural networks are vaguely inspired by the inner working of human brains. The nodes are sort of like neurons, and the network is sort of like a brain itself. For researchers among you who cringing at the comparison, stop pooch and pooching the analogy. It's a good analogy, because some have been popped up and say it is nowhere near to a human brain, but it is like an clone, or we can see it as similar to human brains working principle. So no one really know how to train them, so they weren't producing good results. It took nearly 30 years for the technique to make a comeback, and boy, it did make a comeback, because neural networks are being adapted vastly in deep learning. Actually, deep learning and machine learning can be used with a different kinds of methods and different kinds of networks also. But neural networks are the type which makes the deep learning and machine learning to be more efficient and time consuming, less time consuming. So there are different types of machine learning. Here we have mentioned three of them, which is supervised learning, unsupervised learning, and reinforcement learning. So it is almost its most basic, like machine learning is a way for computers to run various algorithms without direct human oversight in order to learn from data. So machine learning can include running any variety of tasks in order for the machine to determine high probability of outcome for various information, such as the function between an input and output data or a hidden structure in an unlabeled data. So when I say unlabeled data, it is nothing but if you have three kinds of ball and you name one ball as in red, another ball as in blue, another ball as in green, and you train this to a computer, and the computer trains and it understands that green ball is the green ball's color is green, and the blue ball's color is actually blue, and red ball's color is actually red. So that's the label: red, blue, and green. So some data does not have enough label, or it doesn't even, it comes without any kind of label in it. So those kinds of unlabeled data are also being given as an input for machine learning. And the goal or the working of machine learning is to find the hidden structure or a hidden pattern in those unlabeled data. So in instance-based learning, the machine can produce class labels by comparing previous instances. Three ways of learning are summed up in three types of machine learning algorithms. So let's start on with supervised learning. In supervised learning, the most prevalent data is labeled to tell machine exactly what pattern it should look for. Or think of it something like a sniffer dog that will hunt on the target once it knows the scent. So that's what you're doing with a press play on Netflix show. You're telling the algorithm to find similar kinds of show. And this is more kind of a basic type of machine learning. Now let's go on to what's called as an unsupervised learning. In unsupervised learning, the data has no label, it has no teacher. The machine just looks for whatever pattern it can find in an unlabeled data. This is like letting a dog smell tons of different objects and sorting them into group with similar smells. So unsupervised learning techniques aren't as popular because there are less obvious applications. Because unsupervised learning needs more research and more efficient way in order to enhance its kind of learning. So now what's a reinforcement learning? So the last frontier of machine learning, it is the reinforcement learning. A reinforcement algorithm learns by trial and error to achieve a clear objective. It tries out lots of different things and is rewarded or penalized depending on whether its behavior help or hinder it from reaching its objective. This is like giving and withholding treats when teaching a dog a new trick. So to be more example wise, we can say while training, you can have a monkey or you can have any kind of pet, and you train it by asking it to obey the command which you give. So once it obeys, like if I ask a dog to sit down, and if I give him a treat, or we can give him a pedigree or bone, it goes as a reward for the dog. So it understands if the master asks him to sit down, it can earn a reward. So if the dog doesn't sit down, you can penalize it by not giving the treat, or you can do some less harming stuff, or you don't better hurt the dog. It can be any kind of a smooth penalizing thing. So the dog learns that if I'm not going to do, or if I'm not going to sit when a master asks me to sit, I'm gonna no, I'm not the dog understand that it does not going to get a bone piece or pedigree. So that's kind of training should be given to a dog in order to understand, or in order to get obeying to the master's command. So that's what reinforcement learning in a nutshell. So reinforcement learning is the basis of Google's AlphaGo, the program which was famously by the best human players in the complex game of Go. And these reinforcement learning is playing a vital role in robotics also, because for robotics it is this kind of learning or this kind of machine learning, I mean the reinforcement learning helps, or it is much more being efficient for a robot to understand and in order and to develop itself. So we can look into these types in depth, much more in depth. Let's start on with supervised learning. Like we are given an input, for example, a photograph with a traffic sign, and the task is to predict the correct output label or label. So, for example, which traffic sign is in the picture? It can be speed limit, stop sign, or parking sign, etc. In simplest cases, the answer or in form of binary, like it can be yes or no, or zero or one. So supervised learning methods rely on labeled training dataset to learn a function between input variables x and output variables y. The most common types include classification method, regression method, and ensemble methods. So these are common algorithms, and few of them will be discussing in the upcoming slides. So let's move on to unsupervised learning. So in unsupervised learning, there are no labels or no correct outputs. The task is to discover the structure or the pattern of the data. For example, grouping similar items to form a cluster or reducing a data to a small number of important dimensions. So data visualization can be also considered as an unsupervised learning. Data visualization is a topic or is a subject where uh, we want to find the patterns between a data, or we could get a good visualized digital visualization from the given data set. So these methods use only the input variables x, not the output variables, and they rely on unlabeled training dataset to map the underlying structure of the data. So common examples are mentioned in the slide: association method and clustering methods. So again, to reinforcement learning, and I hope you have clearly understood what and reinforcement learning is, because commonly it is used in situations where AI agents like a self-driving car must operate in an environment and where the feedback about good or bad choices is available with some delay. Also used in games where the outcome may be decided only at the end of game. So reinforcement learning methods allow the user or other designated agents to decide the best next action. So based on the current state and learned behavior that maximizes the reward, or it's gonna be getting penalized. This approach, as I said, is the most common thing in robotics. The construction of model layers define what kind of algorithm is going to be used. There are generally four main tasks machine learning solves. This is in general: regression, classification, generation, and sequencing. So these are four common, general, and main tasks of machine learning. So now let's look at some specific algorithms that fall into these categories. Before we start, I hope you could remember what's the difference between algorithm models and algorithm and models. So an algorithm is what used to train model, and all the decisions a model is supposed to take based on the given input to given expected output. So I'll explain you with another example for this. So an algorithm will decide based on the dollar value of the money given and the product you choose, whether the money is good enough or not, how much balance you are supposed to get back, and so on. So that's the model. To summarize, an algorithm is a mathematical life force behind a model. What differentiates model and algorithms they employ? But without a model, an algorithm is just a mathematical equation hanging out with nothing to do. So let's look into few of the algorithms. I mean, few of the famous and important algorithms. Starting on with a linear regression. Despite its name, linear regression is a classification method generally. It's not an regression method. This predictive modeling approach is very well understood. Statistics has been using this tool for decades before the invention of modern computer itself. Super simplified terms, linear regression is a way we analyze the strength of relationship between one variable and another variable, or even more. So the goal of linear regression is to make a most accurate predictions possible by finding out two coefficients that weight each input variable. These techniques can include linear algebra, gradient descendant optimization, and etc. So employing linear regression is easy and generally provides very accurate result. More experienced user, to remove variables from your training data and set that are closely correlated, and to remove much more noise or unrelated output variables as possible. So the next algorithm is logical regression. So similar to linear regression, logical regression is another statistical method for classification that finds the values for two coefficients that weight in each input variables. So when I say two coefficients that weight each input variable, I think most of you would have not understand what it is. Actually, weight each input variable is nothing but how much importance or how much priority we are giving to each input that we are getting from a data. So when we get a data, we can call it as an input to a deep learning or machine learning network. So these inputs we can get, it can be one input or two or even more. So each input should be given each priority or weight, or even we can say it as an importance. So how much we are going to concentrate on each input's weight is the what logical regression is work, like the working principle behind the logical regression and the linear regression. So categorical variables are just variables that can only fall within single category. Good example are days of the week. If you have bunch of data points about things that happened on certain days on a week, there is no possibility that you will ever get to know or get a data point that have happened sometime between Monday and Tuesday. If something happened on Monday, it happened on Monday in a story. That's it. So, but if we think of how linear regression model works, how it would be possible for us to figure out a best line of fit for something categorical. It would be impossible. That is why logical regression models output a probability of your data point being in one category or another, rather than a regular numeric value. It's not a generally binary. It's not an yes or no, or it's not going to be zero or one. That's why logistic regression models are primarily used in classification purposes. So the difference is that this solves problems of binary classification relying on logical nonlinear function instead. So therefore, logical regression determines whether a data instance belongs to one class or another. And it can also provide the reason behind prediction or something linear regression cannot do. So when using this algorithm, limiting correlating data and removing noise is very, very important. Now let's discuss about the classification. Classification and regression trees are easy to learn and use, and they are accurate for a whole range of problems. These are especially speedy to implement, as the data requires no special preparation or it does not need any kind of pre-processing. So more data is better for machine learning models. So where possible image data, for example, instead of needing one hot encode of a data input, modelers will try to create a similar data points from a given ones. So for example of images is in the data set can be flipped, can be blurred, it can be cut, it can be even mirrored out, and it can be stretched out, many different ways to get more data. and more specifically, more labeled data. If the image was a dog before the image was blurred a bit, then it is still a dog after even blurred it. So because we get a different data points from the whole image pixels. The most common neural network architecture for classification is CNN, which means convolutional neural network. And I'm not going to cover this topic in this session because of time constraint. I'll give you as an homework because CNN is a very huge and important neural network and it is being vastly applied and used in computer vision applications. So the next is KNN. Like CNN, convolutional neural network, this is an K nearest neighbor, and one should not confuse this between KNN and CNN. So with nearest neighbor method, the user specifies the value of K. Unlike previous algorithms, this one trains the entire data set. The goal of KNN is to predict the outcome for a new data instance. The algorithm trains the machine to check out the entire database to find k nearest instances to this new data instance, or to find the k number of instances that are more or most similar to the new instance. The prediction or output is one of two things: the mode or more frequent classes in the classification problem, or the mean of outcomes in the regression problem. So KNN works like this. When a bunch of data is thrown on a table, the KNN algorithm begins to sort each into separate categories. A person employs KNN algorithm when solving 500 pieces of puzzles or 500 pieces in a puzzle. Typically, you'll dump the pieces in a table and place each piece into category and easily identifiable color or object of the final image is being used for segregating it. So by shifting and ordering over and over, pieces that share the same color get closer and get a place further from unlike colors. So that's how we'll be solving a puzzle. And in the same way, how the KNN algorithm works. It employs or it can be used to solve a huge number of data or huge 500 piece or 1000 piece of puzzle at a time. So now let's look into the math behind machine learning, because many of them does not give importance or they don't understand what kind of mathematics is really being used in artificial intelligence and machine learning. So in reality, it's a current state that artificial intelligence is just an math, because sometimes it's difficult math and sometimes it requires extensive knowledge of computer science, statistics, and other fields too. But in the end of the day, a modern artificial intelligence is at its core just a mathematical function. No worries if you're unfamiliar with math functions because you don't remember or use them. To grasp this, we only need easy stuff. There is an input called x and there is an output called y. And the function is what happens between the input and output. Function is nothing but the relationship between these two. The relationship between an input and another output is what a function is all about. So super simplified artificial intelligence is just a function expressed as y equal to mx plus b. It means the slope equation. We already know x and y. We just need to find m and b to understand what the relationship between x and y is. So the fancy part is how you teach a machine to learn what function best describes the data. But when you're done, what you are left with is generally in some kind of y equal to mx plus b form. So once we have a function, we can go ahead and know you can find the unknowns. The whole reason we have machine learning is because humans can't look at millions and millions of data points at a time and come up with a complex function to describe the output. Instead, we can use a computer to look into the millions of inputs and millions of outputs, and we can figure out what ties them together. So, as I said earlier, machine learning is nothing but it brings out the pattern in given data set, or it can bring the pattern or formation in a given input and output bunch. So that's the math purpose here. So the math is the basic, or it's a ground level of algorithm. Like if you're learning to build an algorithm, the first step which you need to take is to learn math. So it brings out the relationship between input and an output. So in any case, there must be enough data for correct function to be found. If we only have one data point, call it as an x and y, neither we nor a machine could predict only one accurate function. These are only scratches of the surface of the incredible math and computer science that goes into machine learning. But even complex levels, the concept is same. No matter how wildly impressive or ridiculous machine learning and artificial intelligence may seem, it all stems from functions a machine has learned to best describe the data. And that's the main purpose of math. So as I shown here is an few topics of mathematics which are being widely used in machine learning. So linear algebra, probability theory, statistics, and multivariate calculus, algorithms, and complexity are the few important math topics that one should learn before starting machine learning. So here are a few tips to learn machine learning, how to learn, and these are the few tips which I followed. And I'll it's like an free of cost suggestion. Like if you want to take, just take it because it's much more efficient steps. So I started with learning Python as a beginner first because every there are many languages like R, Java, etc. But Python gives me an good user interface, and it makes much more easier to learn machine learning because I have a background from mechanical department and I don't have an enough knowledge of learning another new language, or I'm not a pro in Java or C++ or any other languages. But I do have a good understanding about C and C++, and that helped me to learn Python very quickly. So pick a foundation course from online and follow it through a couple of months, and bonus points if geared towards uh, teaching data science at the same time, because that's what I'm doing. As I learned machine learning and I learned Python at the first, and I started to teach, because once you teach to someone, it will be going into straight into your head, and it will be more efficient type of learning. Teaching is more efficient type of learning, and that's a great experience which I had in past month. So the second point would be start making things when you're not ready. Because apply what you have learned as soon as you can. No matter how many courses you completed, you will be never 100% ready for anything. Don't get lured into completing more courses as a sign of competence or in order to earn certificates. Because the course you're taking should be only theoretical wise, and it will be surely theoretical wise. Once when you implement something, you will be learning new techniques by yourself, and the understanding level when you implement is a whole another level. So find a project of your own and work on them and learn through being wrong. So the third tip would be there's a lot out there, so reduce the clutter. It means like there are plenty of courses out there. All of them are great, but it's hard to find the best one. But here's the thing: since there are so many, it can be hard to choose. Another trap which can you should hold back. To get around this, I actually made my own degree or my own method of learning artificial intelligence and machine learning. And like that, you can also make your own custom track to follow, and you can make your own path to learn artificial intelligence. I encourage you to spend few days doing research of your own and seeing what's best for you. And research is necessary but pointless if you can't apply. You'll see in articles, papers coming out every day about new machine learning methods and new implementations, applications, etc. Just ignore them. There is no way to keep up with them all at a time, and it will only hold you back from getting your foundations set. Once your foundation is set and you have a solid base, you can just fly off, and you can easily cope up with any kind of advanced technology or advanced implications or applications of machine learning. So most of the best machine learning techniques have been around for decades. What's changed have been the increase in computing power and availability of data. Don't be distracted or demotivated by the new stuffs that will be popping up in your updates. If you're starting out, stick to getting your foundations first, then expand your knowledge as your project requires. Go by project. Start with a simple project, and you go by an intermediate level and to an advanced level. So that's my method and that's my trick.